All right, so let's get started and talk about high strength concrete. So first of all, when we take a step back, we need to understand what high strength concrete is. People refer to this high strength concrete in two different ways. Sometimes they mean it's a high early age strength concrete. So this is typically 12 hours, 24, 3 days, something like that. This is the high early age strength concrete. So you need to get the strengths quick right off the gate. And, typically we're not concerned after 7 days with what the strength is. Um, Ultimate high strength concrete, that's really like a later day strength. So sometimes it really matters what, it might be 28 or 56 or even 90 days. And it's all focused on, can you eventually get the strength of the concrete to a certain level, certain psi. So those are the two different types: high early and ultimate. So the advantages of high strength concrete in general, whichever type you want to look at, um, in essence, early age serviceability requirements and early formwork removal for especially for high early age strength gain concrete. That's kind of what we're focused on. Also for ultimate high strength, that's when we talk about reducing the element size. So maybe you can get away with a smaller column. It's not as big and bulky, or even things like the service design load. You can, you don't have to, things are a lot lighter, especially for maybe it's a high story a building, multi-story building, and so the design load, especially those dead loads, are a lot can be a lot lighter if you can have thinner concrete, and so sometimes you can get away with higher strengths, and you don't have to have as large of a load that for dead load purposes, at least anyways. So you get smaller elements. Ooh. So when we talk about the ultimate high strength concrete, typically ACI defines us at 8,000 psi or higher. It used to be back in the 90s at 6,000 psi and higher, but really we make so much concrete now that meets 6,000 psi. We're not even really saying that 6,000 is even really high strength concrete anymore. 6,500 and 6,000 is not, it's not uncommon to do that every day. So the high strength concrete at 8,000 or above, that's really stuff that you don't always necessarily see every day, unless you're just in a very special market like precast pre-stress facilities, where you need beams to be really high stressed or something. Typically, when we talk about the ultimate high strength, again, we're going to focus, it might be at 28, it may even be 56 or even 90 days, just so that we have enough time so the concrete can properly gain strengths. So it's all about that maximum gain. And we're focused on, having a nice steady increase. Typically, if you have it all start in the beginning, or it can plateau out really quickly. So, we're more focused on it as a strength gain that's steady over time. All right. So maybe you hear things like, I need 10,000 PSI at 28 days. Well, that would be ultimate high strength concrete. So, this is, one of the world's largest buildings in the world. It has a height of 2,700 uh, feet and almost 500,000 cubic yards of concrete. And so it's crazy whenever they built this building, just, a few years, really, at the end of the day, the few years back, and they had columns with a minimum compressive strength at a certain level, at over 11,000 psi. So, they really reduced the size of the elements by getting these strengths even higher. So this is really cool. I believe there's another building that's taller than this one, but it's pretty cool seeing one of the largest buildings in the world, one of the tallest, and seeing how they kind of designed some of that over time. So we talk about high strength concrete mix designs. Typically, if you're going to play with less than 15,000 psi for your, from so 8 to 15,000 psi for your compressive strength, then type 1, type 2 cements pretty commonly used, and even SCMs. So like a class F fly ash or slag, stuff like that, may be used, especially if you're going to get a good benefit from later age strength gain. Silica fume is super common to be used in whether we're talking about ultra high performance concrete or just high strength concrete in general. It really does a really good job of making that matrix nice and dense and really increasing the strength of the concrete. You're going to see a lot of times the water cement ratio that's well below 0.42. And so just kind of realize that there's going to be water reducers that are going to be used to be able to meet the workability requirements, especially as if it gets to be self-consolidating. You're going to be using a lot of mid or high range water reducers, aka super plasticizer, super Ps, whatever you want to call them. But you're going to get something like that so that you can get the workability you need. We talk about high early age strength. This is really more of like time dependent. So you want a certain strength gain within a certain amount of time. So it may be like 12 hours, it may be 14 hours, 24, maybe 3 days, sometimes even 7 days. But typically we're thinking more of like 3 days and below. But most of the strength gain is going to be within the first 7 days, though. And your later age strength gain, because you're trying to focus so much on those, on that early age strength gain, that a lot of times these mixes will actually plateau after 7 days anyway. So it's important to kind of realize that. So things like I need 4,000 psi in 24 hours. Well, it's not at 8,000 psi, but 4,000 in 24 hours. That slope of that curve is crazy. So this would most definitely be a high early age strength mix. And to realize things like high volume pavements where there's lots of rush hour traffic, you don't want to close down a lane or 2 lanes of traffic. And so a lot of times you want to use something that's going to quickly gain maybe 3,000, 4,000 psi, gain enough so that you can reopen that major lane of highway. So high early age strength mixes, things like, they can use type 1 or type 2. A lot of times I'll see a type 3 mix. So type 1 or type 3 is really common to get that initial gain. You may even take out your SCMs because they don't help out as much in the beginning. And typically you're going to be, again, below a 0.42. You're going to see a lot of times accelerators that are going to be used. You may even see a type 3 and an accelerator and not very much SCMs. I mean, it just depends on, what you're trying to do and what performance criteria you're trying to have. And then you also have your temperature focused curing. So like, applying heat in your, for pre-stress facilities, they can apply heat to the beams and to really increase the reaction between the cement and the water and that accelerator. So things like a bridge beam, it may be that that bridge beam needs to be 8,000 psi at 28 days. However, it needs to, for you to release the stressing strands, after they pour that concrete, it needs to be at least 4,800 psi, which is in this case about 60% of 8,000. You also need to ship the beams, so for the beams to be not only released and moved to an area to be stored until it's ready to be shipped, but the shipping strength, meaning you can put them on the on the semi and drive it down the road, usually is at least 80% of the minimum compressive strength. So 6,400 is about 80% of the 8,000. So just kind of be trying to realize that. Another great example of high early age strength mixes is maybe you're storing a high-rise building and you need, just to deform to remove your forms, you need 4,000 psi, which is half of the design minimum compressive strength. So 8,000 psi at 28 days, but the first 24 hours, you'd really like it to be 4,000 would be where you'd want it to meet, so you can take those forms off and move up to the next level. So for major construction, so major things to be working on that slab level. So on that story, you need to have at least 75% of 8,000, which is 6,000 psi. So just kind of realize, different levels as it's gaining strength. You can go from 50%, so you can deform it. A lot of times 75%, you can actually start doing major construction on that slab and on that level, that floor slab, and then 8,000 psi all around is what it needs to be. So it's just important to realize that strength gain over time. You may see at 3 days or 1 day, you may see something like 30% of the 28-day strengths at maybe say 3 days. And then at things like 7 days, you may see something like 60% of your 28-day number. And then obviously, if you're at 56 days, you may be at 100 to 120% of your 28-day number. Typically, you're going to be at, if it's 10 years, it's going to be at least 200,000, or sorry, 200% of your 28-day number. Sorry, so 10 years, 200,000 of your 28-day number. And people always ask me, they go, Dr. Cook, how can we figure out the silver bullet to kill that big bad werewolf? How do we get these strengths so that we can make 4,000 psi at 24 hours? How do we get there? And that's a great question. What I can tell you is, number one, you have to design your mix right. You have to understand that you can't have water cement ratios that are above 0.42. I mean, it's not going to work as well. Also, you need enough cement in your mix to be effective, but you don't need too much. So that can cause some pretty nasty cracking issues if you have too much. Also, your SCM, not only the type, so what your secondary cementitious material is, so is it a class F or class C or slag or a silica fume, but where's your source at? Other things like accelerators, that and retarders, stuff like that can be used in different ways pretty effectively. Water reducers to really improve that workability as you get lower and lower water cement ratios. And then you have like your sources of aggregate and what your nominal maximum size is and stuff. So if just to kind of remind you, if you're trying to hit a certain target, you always want to have a safety above that. So here's some historical data to hit some of those targets. So if you're at, say, 10,000 psi is what you need to hit at 28 days, your design compressive strength is going to be at least 11,700. All right, so when we go to design the mix, we'll go out, we do some numbers, do some math, makes us feel good, it looks great on paper, but we need to go out and trial batch it. We need to test that concrete, because you just never know until you start testing it. So we go out, we test it, and then we say things like, did it meet strength? Did it meet workability? Did it have any other requirements? Did it meet all those? And then we adjust our proportions, we adjust our materials, stuff like that, until we get a mix that performs really well. All right. So one thing that sometimes people ask me is, well, do I need to change out my rock or my paste, or what's going on? Do I need to change my gradation? And I'll say, well, what is your how's your cylinders breaking? And I'm not talking about the brake type that's an ASTM on how to break cylinders, but I'm actually talking about how did it break? Was it a paste break like you see over on the left, or in the middle? Did your aggregate shear off? Sometimes you have a bonding issue with the rocks, like I'm trying to communicate here in the very far right. So where are you at? Where are these different failures like I showed you? Where are you guys at? And in essence, the paste does not bond well with the aggregate particles. That's all about, whenever you have aggregates that are just kind of sticking out of the cylinders like you see here. So that's not good. Sometimes you have dirty coarse aggregate. So you need to really wash it. Sometimes it's because of the smoothness of that surface. So you really want it crushed if you can. Other times you may just not have enough paste in your mix. So kind of realize that. I know one time I had somebody call me up and he goes, Dr. Cook, I'm having real bad strength issues. I'm having reductions of 30 to 50%. Can you help me out? And what I found out was really quickly was that the aggregate sources actually changed. And so you can see here, this is called the mason jar test over on the right. And so the coarse aggregate's pretty dirty. This is after an hour of setting. I put halfway full of rock, halfway full of sand um, on each of these jars. And I filled up the rest of the way on both of these jars with water. So one jar just has coarse aggregate and one jar just has fine aggregate. I shook them up with water and I let them set for an hour and they came back and that's just what they look like. So it was very clear that the holy smokes, that sand, half of it's clay. Well, that really messes up not only air, but it messes up strengths and bonds and everything else. So you got to be really careful to not go in. You need to realize where you're having the bond issue at. Another thing is talking about aggregate shear. So typically what happens is if you have a soft rock or a gradation that's really almost like one size, you may start seeing some aggregate issues, or even if maybe your mix is like that nominal maximum size is maybe too big, and so it'll just shear it. So you got to be kind of careful. Talk about a paste failure. This is actually, you can see here, we've got these little bitty micro cracks everywhere on the cylinder. And so it's actually known to be a weak paste that's caused by poor mixture design, um, high water cement ratio, high air. Again, lots of different reasons why it's common. And I always tell people whenever they're having issues with strengths, remember, it's kind of like a 1950s, 60s rocket ship, 1960s rocket ship. They go out in different stages, and as the concrete's gaining strength over time, that rocket ship is also going up in the air. And so the fuel, it just depends on how much fuel you have in each of those stages. But just kind of realize the cement particles, the C3A, the C3S, and the C2S, and then you have the pozzolanic and cementitious properties. They all act at different times. So just kind of be aware of that. And again, like I showed you before, this is kind of a strength gain over time. So, just kind of be ready and understand, are you looking for early age strengths or later age strengths? Um, and what you do is if you didn't meet your mix, change the water cement, change the sand, change the SCMs, the add mixture, the aggregate, the curing method. Lots of things will play into this mix. So type 2 cement may look like this, the little baby blue line. And then you come in with an ash. It's important You may have something that kind of starts off low, but maybe after 28 days, it may actually kick off a little bit, and it may even be stronger than the normal type 1-2 cement. So another thing is another type 2 cement, and you have a retarder that maybe you use the very beginning. So it's going to start out super slow, but after a while, it's going to really take off. Type 2 with an accelerator. This is going to speed up the reaction to begin with at an early age, and then maybe at 7 or 28, it's going to start plateauing. So just kind of recognize that type 1 or type 2 versus type 3. Typically, a type 3 is either a type 1 or a type 2, and it's ground down finer. So, um, so you're going to have more surface area with a type 3 cement. So you're going to be able to get a quicker takeoff. But again, like I said before, your 28 days or 56 is where things really start, with a type 3, start slowing down. So just be aware. So high early versus ultimate strength, like I talked about before. With the high early, you're going to start out high, and it's not going to take very long until you realize that, oh, I may have made a mistake. My strengths but they did plateau. The ultimate high strength is maybe you started out a little low, and then all of a sudden, after 28, you start getting a lot higher. So here is the maximum the water cement ratio that's recommended for a type 1-2. So if it's, we've kind of seen this and how there's a relationship with compressive strength and water cement ratio, and how air is kind of tied into this also. So just kind of be aware of how all that kind of works. The water cement ratio, that balance, is all about lowering the water cement ratio to increase the strength, lowering the water cement ratio to lower the water cement ratio will also lower your workability. So there's kind of a teeter-totter effect where sometimes you have, you may get better strengths, but you may have lower workability. So that you might want to use a water reducer to compensate. Too low of a water cement ratio, sometimes you may have issues hydrating, or you may be depending too much on your super plasticizer to get your workability, and you may even have some type of chemical shrinkage issue. So you got to be kind of careful. So with that, hope you enjoyed. Hope you enjoyed it. Please leave a comment if you have any questions. Hope you have a great day.